first section of today's notes is simplify, monomial expressions. The first problem is 45 m n to the third power divided by 20 n to the seventh power. Simplifying monomial expressions is just like simplifying fractions. If you have 45 and 20, you can reduce that fraction. 5 goes into each of these. 45 divided by 5 would be 9. 20 divided by 5 would be 4. There's only a single m in the problem, so m would stay the same. If you have n to the third power divided by n to the seventh power, if you remember exponents, you're going to be subtracting when you divide. So 3 minus 7 would be negative 4, n to the negative fourth power. Keep in mind you can still simplify negative exponents. 9m would stay the same. 4 would be in the denominator. Negative exponents go to the bottom and become positive exponents. So your final answer, 9m over 4n to the fourth. Next question, which is the last question for this section. 3xy z divided by 4xz times a second fraction 6x squared over 3y squared. There's two ways to solve this question. You could first multiply the fraction straight across and then simplify, or you can simplify before multiplying. For example, you can cross cancel the 3's. The 6 and the 4, you can reduce each of those by 2. 6 divided by 2 and 2 divided by 2. The x's you can also cancel out. X divided by x and x divided by x. The z's also cancel. You have a single y on this numerator. You have y squared on the denominator. So if you divide out a y, take one y out, you're left with y. And then anything left will be in your answer. All of this got crossed off. We have 3x squared in the second fraction. In the denominator we have a 2 left and a y left, so we have 2y. So final answer is 3x squared over 2y. And again, if you wanted to at the beginning, you could multiply straight across, simplify and reduce, and you'll end up with the same answer. The last section of notes for today is called Simplify. More complex expressions. The first question is 5y minus 5 divided by y squared minus 1. In this question, there's nothing to cancel out at the beginning of the question, but what we can do is factor the numerator and denominator. If you factor the greatest common factor on the numerator, you're left with 5y minus 1. And if you factor the denominator, this is difference of squares, you'll have y plus 1 and y minus 1. After you factor, you'll have a set of parentheses that you can cancel out. And your final answer is what's left over, which would be 5 over y plus 1. Second question. X to the third power divided by y divided by another fraction, negative x over 4y. This time, before we cancel out fractions, we're dividing by a fraction. So we'll have to rewrite the question. The first fraction stays the same, and when you divide by a fraction, you can change this to multiplication, and the second fraction is a reciprocal, or flips over. 4y goes to the numerator, negative x on the denominator. And then from here, you can cancel out. The y's would cancel. 4 divided by 2, you can cancel those. You're left with a 2 in the numerator. You have x to the third divided by an x down here. The negative would stay, but you could cancel out an x, and this would change to x squared. Then what's left? We have 2x squared. There's a negative in the denominator, so you could put over negative 1, or you can just make it negative 2. And again, if you wanted to, you could multiply at the beginning, cancel out, and you'll end up with the same answer. The last question for this section is x squared plus 2x minus 8 over x squared plus 4x plus 3 divided by x minus 2 over 3x plus 3. Couple steps to this one. These first two polynomials, you could factor those. For example, x squared plus 2x minus 8. If you factor that into two parentheses, you'll have x plus 4 and x minus 2. If you factor the denominator, same thing, you'll have two parentheses. It has to multiply to get 3, add to get 4. That would be x plus 3 and x plus 1. Just like the previous problem, we're dividing by a fraction. You can change that to multiplying and take the reciprocal or flip the second fraction upside down. The 3x plus 3, we can actually factor that. If you take out the greatest common factor, you'll be left with 3 and then x plus 1. From here, everything is in factored form, and you can cross cancel. For example, x plus 1 in the numerator, x plus 1 in the denominator. Checking to see if anything else cancels. You have x minus 2 in the numerator and 1 in the denominator. Final answer again is what's left. You have a 3 in the numerator. Also have x plus 4. In the denominator, you have x plus 3. The x's here do not cancel. If it's in factored form, it has to be exactly the same. X plus 4 is different than x plus 3.